All right, today we're jumping right into one of the most mind-bending ideas in all of physics. It's the theory that our entire universe, everything we know, might just be a membrane floating in a higher dimensional space. Yeah, I know, it sounds like pure science fiction, but it's actually a serious proposal to solve one of the deepest mysteries about the reality we live in.
So let's start with a question you can literally test for yourself. Go grab a little fridge magnet. Now, that magnet can pick up a paperclip, right? It's easily winning against the gravitational pull of the entire Earth. Just stop and think about that for a second. That tiny little magnet is stronger than a planet that has a mass of 6 trillion kilograms. How on earth is that possible?
You see, this isn't just some cute party trick. It's a huge, flashing clue. Physicists have a name for this massive imbalance. They call it the hierarchy problem. It's this absolutely baffling fact that gravity is just ridiculously, absurdly weak compared to the other forces, like electromagnetism. Honestly, it's one of the biggest unsolved puzzles in physics today, and figuring it out might mean we have to completely rethink what space itself even is.
So how do we even begin to explain this cosmic imbalance? Well, there's a radical idea, one that was inspired by string theory that suggests our universe isn't the whole story. The proposal that we are living on what's called a brane, that's short for membrane, which is just a surface existing inside a much larger, higher dimensional reality.
Okay, try to picture this. Our entire universe, with its 3 dimensions of space and 1 of time, is like a giant thin sheet. And on this sheet, all the particles and forces that make up our world, we're talking electrons, photons, the whole shebang, are completely stuck. They can move all around on the surface of the brane, but they can't leave it.
So, where is this brane? Well, the idea is that it's just floating around inside this vaster, higher dimensional space that physicists call the bulk. We can't see it, we can't touch it, because pretty much everything we're made of is glued to our brain. But, and this is key, there is one crucial exception.
And here it is. This is the absolute core of the whole theory. While all that matter and most of the forces are trapped on our brain, gravity is different. See, gravity isn't a particle in the same way the others are. It's the actual curvature of space-time. And because it's a property of geometry itself, it's not stuck. Gravity can move freely through our brain and leak out into the bulk.
This leads to a totally game-changing idea. What if gravity isn't fundamentally weak at all? What if its true strength is just as powerful as all the other forces, but it just seems weak to us? Why? Because its influence is being spread out, it's being diluted across all those extra unseen dimensions. We only get to feel the tiny little fraction of its strength that happens to stick around on our brain.
Okay, so if this is the answer, what do these extra dimensions actually look like? Let's open up our first case file, a theory known as the ADD model, named for the physicists who came up with it, Arkani Hamed, Dimopoulos, and Dwali.
The AD model suggests that these extra dimensions are actually pretty big and surprisingly simple. They're flat, just like the 3 dimensions we're used to. In this picture, gravity's strength just spreads out into all that extra volume. So the more extra dimensions there are, or the bigger they are, the more watered down gravity becomes from where we're standing.
And this is where it gets really wild. How large is large? Well, if there are 2 extra dimensions, the AD model predicts they could be as big as 0.2 millimeters. Now that might sound tiny to you, but on a subatomic scale, that is absolutely enormous. It's so big, in fact, that we're right on the edge of being able to test for it with our most precise gravity experiment.
All right, let's move on to our second case file, which paints an even stranger picture. This is the Randall-Sundrum model, or RS model for short, and it suggests the extra dimension isn't large and flat, but small and intensely warped. So in this model, you have a 5th dimension that's super curved. At one end, there's a Planck brane, and this is where gravity is its true, incredibly strong self. Our universe, the visible brane, sits way at the other end, and as gravity makes the journey from their brane to ours through this warped space, its strength gets zapped. It's weakened exponentially. So here it's not diluted by volume, it's suppressed by the crazy geometry of that extra dimension.
So let's just put these two side by side. We have 2 totally different possible solutions to the same problem. The AD model uses big, flat dimensions to weaken gravity by spreading it out over a larger volume. The RS model uses a small, warped dimension to weaken gravity with geometry. And the best part? They make different predictions that we can actually go out and test.
And that is the most exciting part of all of this.
These aren't just philosophical ideas stuck on a blackboard. Physicists are actively, right now, hunting for real evidence of extra dimensions. They're using some of the most powerful and incredible instruments that humanity has ever built.
So the search is happening on a bunch of different fronts. At the Large Hadron Collider, scientists are smashing particles together and looking for collisions where energy just seems to vanish. That energy might actually be a graviton leaking off our brain and escaping into the bulk. Meanwhile, other experiments are testing gravity at super tiny distances, looking for that exact point where it might suddenly get stronger, just like the ADD model predicts. And in both of these theories, we might be able to detect massive echoes of the graviton, these things called Kaluza-Klein particles. Finding one would be like hearing a vibration from another dimension.
You know, whether we find definitive proof of extra dimensions tomorrow or 100 years from now, this whole line of thinking has already been incredibly important. As the physicist A. Perez Lorenzana puts it, these ideas have forced us to look at old problems in completely new ways, and that's always pushing the boundaries of what we know.
And so this leaves us with this one final, awe-inspiring thought to chew on. If any of this is right, then everything we have ever known, every single star, every galaxy, you, me, all of it exists on just a tiny slice of a much grander, higher dimensional reality. It suggests that the cosmos could be infinitely stranger and more wonderful than we've ever even dared to imagine. What else might be out there, just a fraction of a millimeter away, in a direction we can't even point to?